Hello, welcome back to the public policy stage. So we've got two practical things to say. One of them is that if you want to watch any of the sessions again, you can go to the on-demand section and hop in and watch back a session you've missed. And the other one is, as anyone who was in the last session now knows, if you want to ask a question, get it in early. You can type in the question box at any point. You don't have to wait for the end of the session. And the earlier you get your question in, the more likely it is to be asked. So for our next session, we have a fantastic expert panel to discuss new opportunities to use AI to uncover the effects of policy interventions by helping policymakers to understand the impact of proposed measures before implementing them in the real world. The session's going to start with a real-world example. It's a project that the Turing's Public Policy Programme is pursuing in collaboration with the Department for Business, Energy and Industrial Strategy. The project focuses on developing innovative models to capture the high heterogeneity and dynamism of the UK labour market. So I'm delighted to introduce the host for the next session, who will be hosting virtually a panel in this room. So it's a completely hybrid event in every sense of the word, Dr. Omar Guerrero. Omar is Head of Computational Social Science Research at the Alan Turing Institute and an ESRC Turing Fellow. So over to you, Omar. It's all yours.
Thank you very much, Timandra. Welcome to our session, AI for Economic Policymaking, Experiences, Challenges and Opportunities, and it is my pleasure to be your host. I would like you first to invite the audience to submit your questions through the Slido app, and I will try to bring as many as possible towards the end of the session. So before I introduce you to our panel, I would like to take this opportunity to mention that at the Turing's Public Policy Programme, we strongly support the use of computational modeling in the sphere of the public sector. This is why we recently created the Modeling for Policy theme, a research group that will be working on topics such as labor markets, production networks, technological change, housing markets, international development, and government behavior, to mention a few. I will speak more about this initiative at 4 p.m. in a different session called The Role of Computational Social Science in Policymaking, so stay tuned in. Now, I would like to start by introducing to our panel Dr. Cosmina Dorbantu. So Cosmina is the co-director of the Public Policy Programme at the Alan Turing Institute. She is an economist with an interest in working with unconventional data and new modeling approaches to improve policymakers' understanding of the world. She sits on various expert groups, including the Financial Conduct Authority and the Bank of England's Financial Services Artificial Intelligence Public-Private Forum and the Department of International Trade and Economy panel. Prior to joining the Turing, Cosmina was a co-founder and executive director of the largest power market analytics company in Europe. She also spent 5 years at Google, shaping the company's investment and business strategy in Eastern Europe and the Middle East and Africa. Thank you for joining us, Cosmina. Next, I would like to introduce Dr. Catherine Fair. Dr. Fair is a postdoctoral research associate within the Public Policy Programme and is part of the new Modeling for Policy team. She works on the Turing-wide initiative known as the Shocks and Resilience Project. Prior to this appointment, she was postdoctoral researcher at the School of Environmental Sciences at the University of Guelph, Canada. Finally, Catherine holds a PhD in Applied Mathematics from the University of Waterloo, also in Canada. Welcome, Kat. Next, I would like to introduce Mr. Andy Jones. Andy is a government operational research analyst who has spent his career working at the Home Office, HM Treasury, and now BEIS, applying quantitative and qualitative techniques to help improve government decision-making. For much of this time, he was working or leading an internal analytical consultancy, which provided customers with access to a wide range of analytical approaches, from traditional forecasting techniques to systems thinking and multi-criteria decision analysis, giving him the opportunity to contribute to a variety of corporate and policy areas. Currently, he heads a team on modeling and data science at BEIS, with particular focus on exploring the potential of agent computing modeling to support policymaking in areas related to business growth and productivity. Welcome to the panel, Andy. Last but not least, I would like to introduce Dr. Edward Sherman. Dr. Sherman is the current head of analysis for research development and innovation landscape review at BEIS. He has worked and set up various data science teams in government over the last decade. Previously, he was head of advanced analytics in BEIS and head of data science at the Institute for Apprenticeships. Finally, he holds a PhD in mathematical physics from Imperial College London. It's a pleasure to have you, Ed. So before we begin, it is important to mention that although we have panelists who will share their experiences and insights from working in government organizations, they will be expressing their personal views and not necessarily those from BEIS or other UK government departments. Now, it is my pleasure to open the panel with a presentation by Kat Fair about a collaborative project between the Alan Turing Institute and BEIS on modeling the UK labour market through a specific type of AI called agent computing. After that, we will proceed to a broader discussion on the experiences, challenges, and opportunities that these and other types of AI offer to improve economic policymaking. So Kat, the floor is yours.
Great, thank you for the introduction, Omar. With that, I'll move on to this presentation component. As he said, I'll talk you briefly through the project that we've been working on over the past few months. So the thing that we're concerned with this project is looking at the idea of labor mobility. And by that, we mean the idea that people move through the economy when they switch jobs, and the human and social capital that's associated with these people moves along with them. Human capital being things like hard skills, such as coding and so on, as well as soft skills like leadership, people's education levels, and so on. And when we talk about social capital, this can be things like people's social and professional networks that can be useful in their jobs. These trajectories between jobs can be measured through employment microdata, and this can come from a variety of sources, things like government surveys, such as the Labour Force Survey in the UK, where people are tracked across 5 quarters, and at each quarter, they're asked a set of questions about their employment at the time. As well, it can come from things like administrative records, such as those HMRC keeps for tax purposes, or recruitment websites like LinkedIn. Basically, anywhere we can see information about job history, this can be used to build up this employment microdata. And it looks something like this that we're seeing on the screen now, where you have information about some worker. We know some sort of information about the type of job they have. We know when they had it and for how long. And we can see things like how long they were unemployed for, etc. Now, the cutting edge way to represent this data is as labor flow networks. So the essential idea is that we've got nodes in a network, and each of those nodes contains a pool of jobs that has some shared set of characteristics. When people move between jobs, we can imagine them moving between these nodes, and this builds up a kind of very complex network structure. However, there are some kind of recent shocks that have made some of the ways that we traditionally model using these networks a bit more difficult. Traditionally, what we're doing is saying that labor dynamics can be modeled by assuming that workers flow on this network, i.e. that the way that that network is structured prescribes where people can move. So if there's not a link between node A and node B, we're not seeing people switch jobs between those two nodes. And this is a reasonable thing to say because these labor flow networks are really capturing the idea of there being labor market frictions, so factors that would prevent me from moving between those two jobs. Maybe they require very different skill sets, maybe they're geographically very far apart, and so on. So, especially with short-term modeling, it's reasonable to have this idea of the network being assumed. However, the way that this is modeled at this time with things like AI, equilibrium models, econometrics, is not necessarily something that gives us any insight into how these structures form, which is one of the things that we're interested in. And additional to this, we've seen shocks recently, not only the pandemic, but the global financial crisis, Brexit, and so on, that are potentially actually fundamentally reshaping these networks in a way that tells us that using historical data to prescribe how these networks looks is not necessarily a good assumption anymore. An attuned example of this is the idea that, as we all know, over the past 2 years or so, there's been a shift to work from home for many of us. Now, this means that if I was, prior to the pandemic, potentially applying to move to a new job, and I lived in the south of London, I would not necessarily be keen on applying to a job in the north of Scotland because I might have to move and there are costs associated with that. However, now, given that I maybe don't have to move to do that job anymore, I can do it remotely, it could be much easier for me to look for jobs that are geographically further afield, and that would mean we're seeing different links forming in these networks. This brings us to our project goal, which is to look at this kind of broad question of how we can leverage AI, not just to explain labor mobility on a network, but also how the network is transformed by shocks and how these networks form at a kind of much more fundamental level. In order to do this, as Wilmer mentioned, we're developing an agent computing model that produces a digital twin of the UK labor flow network. And as he also mentioned, this is in collaboration with BEIS, who have been really helpful in the development process. It's been a great collaboration for us. So when we talk about these labor flow networks, we mean something that looks like this. This is kind of an intuitive place for us to start with geographical flows, the idea that people, when they switch jobs, potentially relocating physically. But we can also see job switches that are occurring between different industries or between different occupations. And what we're seeing in these figures here is conditional transition densities. Essentially, a darker color means this is a flow that we're more likely to see in the historical data, whereas the lighter colors will be ones that we're less likely to see. So what's on the vertical axes is where you're moving from, and what's on the horizontal axes is where you're moving to. And this is just a way for us to kind of characterize what these networks look like based on some different characteristics of these jobs. So this is the thing that we're interested in looking at and trying to get our model to actually emerge from the fundamental behavior of agents within it through this agent computing approach. So characteristics of the model, we have jobs that are created and destroyed, and these jobs are heterogeneous, so they have different salaries associated with them, different skills required to perform them, different types of contracts, so full-time, 0 hours, etc. And we also have agents that are heterogeneous. And when we talk about heterogeneous agents, this can be in terms of how old they are, how much accumulated wealth they have, factors that would impact the sorts of decisions they're making about their careers, how long they can remain unemployed, etc. For example, people who are very wealthy are potentially able to remain unemployed for longer than those who don't have very much accumulated wealth and might just need to take the first job that becomes available to them. These agents search for and apply to jobs, and they're considering their career prospects not only based on wages, but on things like geography, industry, and occupation, looking to build their careers over time. This model leverages large-scale labor microdata to instantiate a one-to-one population. In other words, an agent in our model is equivalent to a worker in the UK labor market. And with this model, we're able to emerge the UK labor flow network organically. And what we mean by that is, say we have some jobs that are represented by these white circles. We know the characteristics of these jobs, so they're grouped by industry, occupation, and region in the model. And we also have some agents. Some of these agents are employed, so the ones that are within one of the white job circles, and some of them might be unemployed, so they're just floating on a node. Over time, these people are searching for new jobs and applying to them, and some of them will be hired, and we'll see them switch jobs. Now, this red arrow set is what we're considering to be a baseline, which would be a model calibration that allows us to reproduce these historical flows. But we could also see alternative scenarios that would be interesting for policymakers to explore. For example, the idea that we could see some jobs appear and disappear, as we've just seen here, because of changes to the labor market, whether that be international free trade agreements, whether that be drastic changes that are technological in nature. And not only could we see jobs appear and disappear, but we could see things like different wages being associated with certain jobs, different skills being needed to do different jobs. And under this kind of shock scenario where something has fundamentally changed some of the underlying kind of environment that people are making decisions in, we might end up seeing people start to make different decisions about where they're moving. So in this case, we see this. And we would imagine over time, with a larger system that's not just 4 nodes, we can end up seeing very different network structures emerge from a kind of baseline business as usual scenario based on the historical data versus some sort of shock scenario where some kind of drastic event has occurred that has fundamentally changed the environment in which people are making decisions about their careers. With that, I'll kind of come to our conclusion. I should emphasize that when we talk about the baseline, we mean that we're kind of calibrating, I should say, this red scenario such that it matches the historical flows. And this is our way of validating the model before we start performing policy analysis with it. So this example we've come up with here, this agent computing model, is, in our view, a powerful tool for policymakers that is able to combine AI principles, in this case, agent computing modeling, with big data, like the labor force survey data that we're using here. And these types of tools really add value because they're providing granular insights. So you can imagine here, because we have agents in the model, we actually have information about specific workers, and we can track those workers over time. which is not the case with certain other types of modeling. It's also providing us a causal explanation for how these networks form, which is not something that other models are able to do. And finally, it gives us the flexibility to explore policy relevant scenarios like that blue scenario of shocks we described earlier. We can kind of consider what sort of shocks might be interesting for policymakers to look at and tailor our approach as such. So finally, I'll acknowledge, of course, my employer, the Alan Turing Institute, as well as UKRI and EPSRC, who funded the Shocks and Resilience project that I work under, and finally our collaborators at BEIS. And with that, I'll move us on to the roundtable discussion.
Now it's time to move to the discussion with the panel. And I would like to start perhaps by asking our guests from BEIS, what would be the pressing UK economic policy challenges that you think AI is well positioned to address? And perhaps, Andy, you could start with your take on this issue.
Yeah, sure. Yeah, thank you very much. Very happy to do that. So my feeling is actually that the pressing issue is a fairly general one. So to understand the environment in which our policies operate, and in the case of the economy, obviously this is understanding the economy. Obviously, government's aiming to produce real-world impacts. But in order to do this, we need to understand how the system that our policy is operating in is going to react to any particular intervention. And when I say understand the economy, understanding the whole economy obviously is a huge challenge. So I think understanding aspects of the economy that we can actually model and understand separately is a much more realistic goal. And the work that Kat's just talked about is part of that. Other areas, so labour mobility, is a really important area. Underpins productivity, which is something government and particularly BEIS is particularly interested in. But there are lots of other areas: skills, innovation, investment. It would be great to understand those systems in a bit more detail. And of course, specifically, there are a lot of challenges that we've had over the last few months and years. COVID, energy availability and prices, labour inactivity, and now a war in Ukraine, all of which throw up challenges for the UK economy. And I think AI and agent computing, which is my area, is well placed to help us understand how aspects of the economy might react to those things. That's not to say that it's easy. I think it's very challenging, and we might have a chance to talk a little bit about that, what the challenges are a bit later on. But those are my thoughts. Yeah, a sort of a more general challenge to understand how the economy works the way it does, how it might react to interventions. I don't know, Ed, have you got anything to add? I'm sure you do.
Thank you, Ed.
Very happy to reflect. Stepping back slightly, or up a level, in terms of what AI is well positioned to help with, in some ways it's downstream of bigger questions, which is, I suppose, the bearish case on it. Can't tell you what's right or what the right area to look at is. And then in terms of our work, it is often then also downstream of the simple insights that we can try and give people to help shape their thinking. I think I've had the most success and influence with a bar chart rather than sort of some natural language processing or anything like that. I'm sure that's a familiar feeling for everyone. But having made that maybe bearish point, it's really good for surfacing our assumptions and biases. As was discussed in the previous section, there's that kind of T.S. Eliot little Gidding quote about not ceasing in our exploration, but then when we get to the end, we know the place for the first time. And there's definitely an aspect of that, particularly in this work, say with what's going on in the labour market. But yeah, policy making, I don't know, it's mostly operational impacts, I think. So that's a really rich area for AI, or improving our ability to collect statistics. But to make that a little more concrete, so before my current role, I was in test and trace, running demand and capacity modelling, and that was a situation where having a digital twin of the lab network was really invaluable, both for operational decision making. We could optimise the network, we could make decisions hour by hour and day by day, then also running scenarios to help us plan for different eventualities months in the future. So it's that kind of crossover area between operations and policy it's the kind of the rich vein. So I've probably said more than enough like there. Omar, do you want to redirect me?
That's great. We will touch on some of those topics in a little bit. Perhaps we want also to hear from the Turing side. So Cosmina or Kat, do you have any take on this?
Yeah, well, I'm a trade economist. That's what my PhD is in international trade, and I think this idea that I was talking about earlier as well, that we're used to modeling the world from aggregates, and I think that's particularly the case when it came to international trade, and this was one of my disappointments as a researcher, that the tools that we had to look at this like highly complex interdependent phenomena were either sort of models from the aggregate or regression analyses to try to identify some like tiny effect. But and I think what we know about trade is that it's beneficial in the aggregate, and this is what has been driving this entire globalization agenda. And it's true that it does lead overall to higher economic growth. But what we've also known about trade from the very beginning is that it does have a distributional impact. You win as a whole, but there are parts that end up losing from it. And we haven't been able to capture that. We haven't been able to focus on that in the past. I think a lot of the sort of anti-globalization movement that you see these days is due to the fact that we have neglected the people who have been losing from this to the benefit of the people who have been gaining from it. And I'm really keen for us to turn our attention to modeling those phenomena and trying to understand a little bit better who's winning and who's losing from a particular policy, and how can we compensate those who are losing so that we don't lose something that could be beneficial for us all. And I think that's probably one of the things that I find so excited about the Turing, that we are setting up a program of research in this area, and we will be looking at things like international trade and trying to address it in a way that economic policy helps people. It doesn't just enrich a few, but it helps people, and we understand how to do that.
Thank you. Kat, do you want to add anything?
I would just say I agree with Cosmina that kind of the models that we're traditionally using for these types of questions about the economy are an aggregate, and so transitioning towards something that gives us more granular outputs does allow us to see, she says, who's winning and losing, and address issues around equality and equity, things that I think are central to a lot of goals at a high level for governments and for NGOs at this time.
Thank you. Excellent. So yes, indeed, all of you have mentioned key aspects where AI has opportunities, right? There are topics that have to do with interdependencies, high disaggregation, operational issues, etc. And this is great, I think, to know what are the key opportunities for this technology. But I think it would be also useful for the audience to understand where are we standing currently in terms of adopting AI. So my next question has to do with that, and it is precisely asking you to comment on any successful experience, if any, that you are aware in the adoption of AI for economic policy applications. And perhaps I would like to start with Cosmina. Cosmina, you have been sitting in many panels and many forums. So if you could give us some of your insights first.
I think we're very much at the beginning of this journey, and in a way that is what is both exciting and sort of daunting about it. And what's exciting about it is that we have a world of opportunity ahead of us. And I think we're starting to prove the potential of these technologies, and we're starting to convince policymakers of the opportunities. So I think we're starting out small with like little projects that we hope they're going to be growing into bigger ones. But there's a lot of excitement and there's a lot of sort of desire to capitalize on this potential. What's a little bit daunting is that whenever you're the one who's building the road, there's a huge responsibility that comes with that, I hope we're gonna do as well as we can with these technologies. I really hope that the beginning is gonna work out. The risk in government is that you start with something and it fails, and then you never want to go back to it because it has failed once. So the starting point is very important, I think.
Thank you. Ed, you have set up many data science groups across the government. So what is your opinion on this?
I can tell you a couple of stories maybe about where it's happened. So recently in BEIS, we set up an advanced analytics team to give ourselves the capability to use real-time indicators to assess what was going on in the economy and the behavioural impacts of COVID. This was back in March 2020. So I spent a year on that. And that was really valuable in two ways. I think one was pushing us into a kind of a new way of working, so that we could become, I suppose, better customers of this work, and we could become better at communicating the value of it. It was also really valuable to be used kind of internally for insight and to be able to kind of prototype the way we can engage from a lot of different angles on kind of emerging areas of interest. So, the labour market being a case in point, can you use faster indicators like job postings alongside your more traditional metrics to get a richer insight into what is happening and how your interventions are taking shape. I think my team gave a talk at the Institute for Government Data BEIS on the use of real-time indicators recently. So that was fantastic. But yeah, I think there are the beginnings of work in a lot of areas. All the ones with these big parameter spaces like net zero, economic transitions in responses to regulation or other shocks and changes. So from the BEIS point of view, those are the kind of really exciting areas.
Great, thank you. Kat, from the point of view of a researcher, are you familiar with this type of experiences?
Yeah, I mean, obviously, as Cosmina said, it kind of feels like we're at the beginning of this, that there's a lot of interest that we would obviously like to capitalize on to be able to demonstrate that there's value in the types of things that we do at research institutes as academics, that we can come to someone like BEIS and be able to, provide a compelling case for why this should be used. And I think even going beyond economic policy making, what the pandemic has done is really kind of bring to the forefront of people's minds the idea that modeling adds value. Not only people in government, but just for the public. I feel like prior to the pandemic, we wouldn't have seen very much awareness of the idea that we can do predictive modeling, real-time modeling, and with COVID, it's really kind of an opportunity for us to kind of get our foot in the door as researchers and say, this is an application in which the type of work we're doing has added value. Are there other places, for example, in economic policy making where we can add value as well?
Excellent. And Andy, what is your experience with successful absorption of AI?
Well, obviously Kat has talked about one of our successes, and it was great to hear her talk. I think what I'd say is just really to echo what I think everyone else has said. Cosmina started by saying that we're at the beginning of a journey, and I think that's very true. I have learned a lot over the last few years from trying to apply agent computing to problems of interest to BEIS, understand the economy, as I mentioned earlier. And they haven't all been as successful as the one that you've heard Kat talk about. And I've come to realise that we're not ready to produce models of all of the things that we would like to. To do that, you need either data or a theoretical underpinning for your model, or ideally both. And there are some areas where we just don't have that, and you can't just jump into producing a model of something like that. Well, you can, but what you end up with is a hypothetical model. You're saying, well, if the world worked in this way, then we'd expect to see this behaviour. And those kind of models are interesting, but if we want to influence policymakers, I don't think that's really going to work. They are very interested in the data underpinning the models, the theory underpinning the models, and yeah, that's very, very important to be able to communicate that. Yeah, so really just say, yeah, I agree. We're at the beginning of a journey. Still a long way to go. But I've learned an enormous amount from the very first couple of years working on this.
Thank you, Andy. And you mentioned indeed important aspects that relate to the challenges, and that's something you mentioned earlier on as well. So I would like to direct the discussion precisely to that topic, to the challenges in adopting AI, and more particularly the fact that many times, even if you have all the technical skills to develop certain technology, adopting it is many times constrained by existing practices or policy frameworks that are already in place, are incumbent to the organization. So I would like to ask you, perhaps, Ed, you can start. I would like to ask you, what do you think are the main challenges in absorbing AI into existing policymaking frameworks?
Oh gosh. Well, look, I think it's not going to be any surprise because of the same barriers that we all face kind of everywhere with this. So there's the barriers around communication. I think that will be familiar to anyone that's run a data science team. Communication and explainability. So saying, well, the neural net said that this was a good idea, it doesn't convey the same level of confidence to somebody who doesn't have a kind of sciencey technical background. Andy also raised the issue of that theoretical kind of underpinning, which is very important. You need to be able to explain what's happening and why, and connect it intuitively to policymakers. I mean, the other things that I think bedevil all of our projects are, issues around quality of data. It's been collected for one purpose, but you're trying to use it for another, or bias in the data. I think our colleagues over at the Ministry of Justice will be familiar with this, and I'm sure this has come up in various situations before. So yeah, trying to account for data that reflects human biases in a flawed process. And then there is also just the issue of the culture and structure of the civil service. Not in a negative sense, but that we reflect the pressures that are put on us, and often we're having to do really interesting work, but we're having to do it very fast and react to events that emerge, and this is not always conducive to the kind of focused time that you would want to develop new capabilities and really test them. So there you go. Those are the key challenges as I see them. They're probably familiar to all of you.
Fantastic. Thank you, Cosmina.
No, they are very familiar. I think from the researcher side, what our biggest obstacles at the Turing have been data access. How can we get access to the data sets that we would need, and also the time scales. Research works on a different time scales to policy making. We like to take years to think about a problem and to sort of perfect our approach and to change it. And usually policymakers, when they come to ask us for an answer. They needed the answer yesterday, you know. So sort of trying to find ways to work together. And I do think, you know, I'm so grateful to our colleagues at BEIS, because I think this has been such a brilliant collaboration, and you know, we're sort of building it up as we go, and it's never been this sort of like huge time pressure of, you know, let's have this like 3 months project and then we need to deliver everything then. And you know, we're learning from each other, and we're building together, and I think that has been such a good way of doing things.
Great, thank you. I guess this speaks very closely to Kat's experience regarding making research work with existing policy frameworks. What do you think about this, Kat?
Yeah, I agree with something Andy mentioned earlier, which is the idea that, you know, if we're wanting to actually have people buy in to the type of work that we're doing, we need to make sure that what we're bringing to it methodologically is something that actually is appropriate to the questions that policymakers are interested in. So for us, we have this great fit right now that agent computing is a really good way to tackle questions that BEIS is interested in surrounding employment and skills and so on. But I think often there is a kind of disconnect between the type of modeling that academics do and the types of questions that need to be asked. So it is a good thing to kind of think carefully about what is a good match between these two things.
Excellent, Andy.
Yeah, I mean, I would agree absolutely with what's already been said, particularly on the speed of response point. You know, timing is really important to policymakers. A lot of policy areas are fast moving, but I think if we focus on building models or AI products that can address a range of things that we know are going to be of interest in one way or another, then I think that's a way of kind of acknowledging and dealing with those fast response times that are going to be required. So when we started on the journey of building the labour flows model, I had in mind that we would use it for something like, you know, the closure of a large factory. You know, so a lot of jobs are taken out of the labour network. What happens to those workers? And we may still use it like that, but there have been other things that have cropped up along the way that we hadn't conceived of. I mean, the pandemic is the obvious one, but a rise in economic activity is another one. So rather than looking at a reduction in the number of jobs in an area, we might be looking at the reduction in the number of workers. And that's something that I hadn't really thought about at the time. And yet, the model we have, or the model we're working on, I think is in a good position to respond to those. You know, it's flexible, we can change it to address the specifics of the policy issue that comes up at the time.
Thank you, Andy. And these are great interventions. Thanks, all of you. I have a very long list of questions that I would like to ask you, but I think it is also important to get questions from the audience. I would like to take now this time to bring up to you some of the questions. So I invite the audience again to submit your questions through the Slido app and to vote for questions. So I will be presenting them according to their popularity. And please, the panel, feel free to answer in the order that you wish. This will be a little less structured. So the first question brought by the audience has to do with privacy. And it is, what is the potential privacy/legal issues with using microdata of individuals? How can they be avoided?
I think, speaking from the perspective of the project we're working on now, we're obviously very cognizant of the fact that privacy is an issue, data protection is an issue, and so the data that we're using for this is something that the ONS and we take very seriously, kind of making sure that everything we're using is anonymized and making sure that you know, anything we take out of the secure system that we access the data through has been checked over, because obviously if we would like to continue having access to this type of data and we would like people to continue to provide it, whether that be through surveys and so on, there obviously needs to be trust between researchers and the government and the public who are providing this data. But I think as well, there's kind of potential for us moving forward to start thinking about if there is data that we know we want to link. Right now, there are privacy issues with doing that. So it would be good to kind of build in to these surveys, either making sure all the information you want is on the same survey, or making sure you have an agreement in place that we would be allowed to create linkages in a way that still preserves the privacy and prevents data protection problems.
Thank you. Anyone else in the panel?
I would add that, that's something that we take very seriously at the Institute, and we've written the government's public sector guidance on the responsible use of AI technologies in government. And there are many things that one can do to sort of ensure that you are protecting the privacy of individuals, and that you are using these technologies for the public good. And as Turing researchers, we do have to go through an ethics approval process whenever we set up a project, and I think that's very important. I think it's very important that there's an ethicist at the table for all of these discussions and for all of the projects that we're going to be building. We're not going to make any progress with these technologies in the public sector unless we make ethics considerations a priority and a part of data science itself.
Thank you. Our guest from BEIS.
Yeah, I mean, I don't have a lot to add to that. Obviously, government very keen to make use of the data that we do have, and lots of initiatives to help that happen. But at the same time, it's important to balance that against the needs of the individuals whose data it is. To balance that against any benefits to society of sharing the data, using it for research and so on.
Yeah, I would say from my personal reflections that we default very heavily on the kind of risk aversion side here. We are not capturing the potential benefit. So, privacy and propriety around the use of data is taken seriously to a fault within government, to the extent that it inhibits work with external partners, it inhibits our internal work even. And maybe this is a question for the data ethicists, is at what point does it become, regressive in the extent to which it maybe blocks innovation and benefits from occurring. But yes, in terms of practical day-to-day stuff, yeah, we take it very seriously. We generate synthetic data, and we're very careful not to either lose or endanger people's privacy.
I think that
Thank you very much.
What I would add to that, Omar, is that at the beginning when we set up the public policy program at the Turing, we went and we talked to government departments, to hundreds of people, local authorities, police forces, to try to understand how they're using these technologies. And what was very interesting in those initial conversations is that there was almost nothing happening in central government, precisely because of this idea that people were very risk averse and nobody wanted to sort of, take the plunge. But where a lot of movement was happening in terms of, the use of data science, and actually where a lot of the problematic uses of data science were within some police forces, were with some local authorities. So it felt like local government and local police forces were a little bit like the Wild West, but central government was very, very, very cautious in its approach. And I think we're getting there, but I think I think with ethics, you need the proper procedures in place and the proper guidance in place before you can actually take on these projects with confidence, and that's what we're trying to build for this work to move forward. Ethics should be an enabler that allows good science to happen. It shouldn't be a stopping point.
Yeah, we don't want to end up in a world where you can be targeted for cat food very easily, but the government is unable to join up its services.
Yeah.
I'm thinking of cat food, so I've just got 3 kittens, so it's on the brain.
Great, thank you. I want to move on to the next question, so we don't monopolize one person in the audience. So let me move to the second most popular, which is asking, how likely does the panel think universal basic income initiatives will be implemented as AI becomes more commonplace?
My reaction is that we're desperate for robots. We need robots as quick as possible. We're not worried about running out of kind of work and things to do. So I'm not sure that there's a short or even medium-term need for something like a UBI. And on the other hand, we already have both universal credit and a pension system. So to an extent, we already have it. So that's my bearish take on UBI is that I cannot wait for the robots to come.
Any other take on this?
I mean, I think much like, the story about trade, we're talking here about technological innovation and technological progress. And, sure, there will be a lot of aggregate gains to be had from this, but AI, much like trade, will see winners and losers. There will be some people who will suffer from this technological progress. And I think we will have to find a way to compensate them so that everybody has a sort of minimum standard of living. And I think that's something that we will have to give thought to. Whether that's going to be in the form of some universal basic income, I'm not sure, but I think we do have to give this very careful thought.
Yeah, I mean, I think I agree with that. I don't see a need for universal basic income anytime soon, but I do think we need to adapt as the labour kind of landscape changes.
Kat, do you want to close this question?
I guess I'll just say I'll defer to Cosmin on this as the economist in the room to have a more informed opinion than I do on it as a mathematician. Broadly, I agree with her, though, to be fair.
Thank you. Thank you. So I have time for one more question, and this has to do more with the modeling. So the question is, does this model factor for people who have multiple jobs concurrently?
So the current iteration of the model, the version that we're working on calibrating right now, does not. However, this is something that Andy and myself and Omar have definitely discussed as a thing that we care about looking at moving forward, particularly in the context of the idea of job precarity, with the idea that people on 0 hours contracts, so for example, if you're a delivery driver, perhaps you're also an Uber driver and so on, in which case it is important for us to factor in the idea that some people have multiple jobs, whether that be out of necessity or because they just enjoy having multiple positions. But it is certainly something that we're cognizant of being an important factor that's not currently in the model.
Thank you. Well, this was a very specific question, so I expect Kat to make a comment, unless someone else has a comment as well. I can squeeze another question.
All
right,
right.
so
to what Kat says, lots of developments that we'd like to introduce to the model, and that's one of them, certainly. Yeah.
Excellent. Thank you, Andy. So the last question of the session is the following. Often there are systemic challenges with existing legacy tech that collects data and legal barriers to data sharing. How did you overcome these challenges?
I think we can have another whole session just on that, but it's true. And it's not just in government. When you're looking at large financial institutions like banks, for example, a lot of their data, banks sit on highly valuable data, and a lot of them cannot use the transactional data because it's sort of locked away in legacy systems. And it's the same within government, and I think a lot of the sort of technological, like IT contracts, are a barrier. How we get out of that, how we actually, sort of take advantage of all the data that the government is sitting on. I mean, that's a huge question, and a highly important question. The government does have an awful lot of data. It's just not in an easy-to-use format at the moment.
Yeah, I would say I certainly agree that it's kind of a big challenge for any sort of AI application that requires long spans of time series data. So essentially, if I want data that goes back to 1960, there are obvious technological issues that are barriers to me getting access to that data and for it all being even just formatted correctly or consistently. So I think potentially one of the things moving forward is that we need to kind of build that into the way that data is collected and kind of be more accountable for having this consistency from the start, because it'll give us a lot less grief in 10 or 20 years if we're kind of having this be a thing that's built into the way that we're collecting data in the first place.
Yeah, I mean, I think the question asked for examples of where we've overcome these challenges. I'm not sure I have any, but certainly the kind of things that we should be looking to do are improve data quality. I think it's always easier to share high quality data than data with lots of caveats attached to it. A clear understanding of what data we have and where it is and what form it's in. I don't think that's actually widely known. Adoption of standards, obviously. Culture, we talked a little bit about maybe a risk-averse culture that would need to change. And we also talked about ethics. So all of those things, I think, need to progress to get us to a better place on overcoming some of those barriers, I think.
In terms of success, the LEO was a big success. This is longitudinal educational outcomes, stitching together disparate data sets from further education, higher education, schools, and then linking it to labour markets. But that started by a couple of analysts sort of just getting stuck in to try and improve the little bit they were working on in further education, and then gradually grew out from there. So it does happen, and you can just make a start and make the world a better place. But fixing the data plumbing is not sexy, and it's rarely prioritised.
Great, thank you very much for all your comments. I'm afraid we have reached the end of our session. This has been an extremely insightful one. And I would like to thank again our fantastic panelists for their time and for sharing their experiences. And also to the audience for being here with us today and sending us their questions. So please stay tuned, as there will be other exciting sessions in the public policy stage, including one at 4 p.m. on the role of computational social science for policymaking, featuring 3 of the founding figures of this emerging field. Thanks again, and see you later.